In this video, we're going to take a look at solving compound inequalities. We have two types of compound inequalities. We have conjunction inequalities, and these are ones that are joined by the word and. That means that both of these things must be true to find an x value that is a solution. A disjunction inequality is combined by the word or, and that means that either this can be true or this can be true. Just one of them will be true, and then we have a solution for x. So let's take a look at how we solve these inequalities. First, we have a conjunction example, and we have two inequalities combined with an and, as we said. So all we're going to do is we're just going to solve these separately. Nothing too fancy. We've got to remember our rules for inequalities. Solve it like an equation. Add 5. 9 is less than or equal to 3x. Divide by 3. And we get 3 is less than or equal to x. Over here, we're going to take our 2x plus 1 is less than 11. Let's subtract off our 1. And now we've got 2x is less than 10 divided by 2. Only thing we've got to watch out for is when we divide by a positive or negative, we'll have to flip the sign. But that did not happen here. So we have two inequalities. We know that x has to be bigger than 3 or equal to, and it has to be less than 5. And so if we graph this, we have 3 and 5 over here. And we're going to use our interval notation kind of brackets. We have 3 is included, so we'll put a hard bracket there. And this is all the numbers that are greater than 3. Well, that's these guys up here. And then we have all the numbers less than, let's grab a different color here, all the numbers less than 5. And that's going to be a soft bracket because it's not included. And that's all these numbers going over this way. The solution is where these overlap. So the and means that we're going to go in between here. And that will be all of these in between. Let's see. Let's go like this. Okay. So in between is where we get our solution. All right. So the final graph would include 3, have a round bracket at 5, and we have this in between. All right. So that's our solution set. And to write that, we can write that as an interval from 3 to 5, not including 5. That's interval notation. Or with set builder notation, we can say the set of all x's such that x is greater than or equal to 3 and less than 5. With an and inequality, we can glue them together. So either of these would be an acceptable solution for that. All right. Another type of conjunction here might look like this. Even though this looks a little strange, we've got two inequalities. This is just an and situation. So we have 4 is less than or equal to 3x minus 5 and 3x minus 5 is less than 11. So with this situation here, we got to split it up. First thing you got to do is split it up. And then we're going to solve it like we did before in the previous problem. Add 5. 9 is less than or equal to 3x. Divide by 3. And we've got our answer just like we did before. Here, let's go ahead and add 5. 3x is less than 16. Divide by 3. And x is less than 16/3. All right. So again, the key is split into two inequalities like this with an and. Then solve both of them separately. And we will end up with our solution here. And we can graph it. We know that it includes 3 and all the numbers to the right. And the boundary on the right side is 16/3, which is 5 1/3. And all the numbers to the left. And these two sets overlap in the middle. So we'll kind of shade it in between here. So there's our graph. As an interval, we have 3 and 16/3. That's a good solution. Or, as an inequality, we can say the set of all x's such that x is greater than or equal to 3 and less than 16/3. All right. So once you split it up, it becomes the same as the previous problem. Now let's try a disjunction. Again, with a disjunction here, it's going to act the same as we did with our conjunction, with our and. Just solve them separately using our rules of inequalities. You've got to subtract 5. Negative 2x is greater than negative 22. Here we're going to divide. Oh, I'm sorry. Let's back up. This is not a negative. So this is a positive 17, which is going to give us a positive 12. All right. Divide by negative 2. When we divide by negative 2, it's going to flip the sign. And this is going to give us a negative 6. All right. And then we take our second one over here. And we have 10 is less than or equal to 3x minus 14. Let's add 14. And we got 24 is less than or equal to 3x. Divide by 3, and we get 8 is less than or equal to x. Now, in this case, when we graph this, we have two boundaries. We've got 6 and we've got an 8. But the graph of these points is going from 6 and down to negative infinity. 8 is included, and we're going right to positive infinity. These don't overlap, but we're not looking for the overlap. This is an OR. An OR kind of glues these together. So that's our graph. We can describe this as going from 6 to negative infinity. And this is going from 8 to positive infinity. And we glue it together with a union. So that U symbol there is a union symbol. In set builder notation, we can say the set of all x's such that x is less than negative 6 or x is greater than 8. And that's our set builder notation. Notice we cannot put these together into one inequality because they don't overlap. And there you have it. So we have disjunction, solve them separately, and they end up staying separate. With our conjunction, we do the same thing, but we can kind of put them together in the end. Good luck.